Hey everyone, Luciano here. Before we jump into today's video, where we're going to break down one of the most talked about incidents in cloud security history, the Capital One breach. So I want to take a moment to share something valuable with you. So if you're working in cloud security or aiming to get into this field, you know how fast threats are evolving. So that's why I want to highlight an amazing training opportunity from NotSoSecure, one of the leading providers of black hat training. So their instructors aren't just teachers. They are ethical hackers who spend half of their time working on real-world cybersecurity projects. So that means that you are learning from people who are actively securing systems in the wild. So their course, Hacking and Securing Cloud Infrastructure, goes deep into vulnerabilities across AWS, Azure, and GCP. It covers everything from IAM misconfigurations to container security and so much more. So if you are serious about cloud security, this training is a no-brainer. So you can check out the course here, Hacking and Securing Cloud Infrastructure, NotSoSecure. I'll put the links down here for you. Here's a bonus. So you can get a 20% discount on their upcoming courses. Just email NSS Tech or Dash Training at claranet.com, mention my name, and you get the offer. Yeah, NotSoSecure is also part of Claranet, offering some really solid cloud services. So we can explore those here, Claranet Cloud Solutions. So all right, now let's get into what's really happening in the Capital One breach and what we can all learn from it. Enjoy it.
The next security breach I want to talk about is the Capital One breach that happened in 2019. In this particular breach, there were over 100 million consumer credit card applications that were stolen. These applications had social security numbers on them. For the Canadian applicants, they had the equivalent to the Canadian social security numbers as well. This particular attack was conducted by a lone hacker who used to be an Amazon employee by the name of Paige Thompson, or code name of Erratic, and the impact was quite significant. As opposed to most breaches these days, which are conducted by organized cyber criminals or nation-state adversaries, this particular attack was essentially done by a single lone person, former Amazon employee, and she was caught very quickly, given a $250,000 fine and 5 years in jail. But impact to Capital One was much more significantly. This breach costed Capital One over $300 million. And while that seems like a big number, given the number of records that was stolen, over 100 million, it's about $3 per record. It's not a lot per record, but overall it sums up quite a bit. How did this breach happen? And then I was going to walk through a set of technical diagrams showing exactly how this attack was done. But at a high level, it had a firewall rule misconfiguration that allowed Erratic to access the Amazon S3 buckets that were used to store 100 million credit applications. There was also a virtual machine that had a vulnerability called server-side request forgery vulnerability, which I will also talk about it. But that's pretty much how the attack was able to technically be executed. It could have been prevented through perhaps a more rigorous firewall review. It could have perhaps been prevented by cloud security scanning. And one of the things that keep in mind about cloud services is, in general, is that specifically at this stage, they make a lot of features and functionalities available to their users And there are hundreds, if not thousands, of configuration parameters. And in order to achieve security, all the relevant ones need to be set exactly right. If there is even one that is off, then it may give the attacker the ability to get an initial foothold into the environment. So with that, let me go ahead and talk a little bit about some of the technical details on how this particular cloud security breach occurred. By the way, I think the Capital One cloud security breach at this time was definitely was a large security breach that's true even today. So of course we see a little bit of a word where there is a new breach every month. So we'll see how long it will take to pass this record. But in any case, let me talk about the Capital One breach in its diagram. Okay, the left side of the diagram, I have the attacker's machine. On the very right side of the diagram, I have the virtual machine, which is called an EC2 instance, Elastic Compute Cloud Instance, in which a company or an organization can run their own code, run their own processes in their workloads. And so that's what's depicted. And to the right is a metadata service. So when services run inside a virtual machine on a cloud, on Amazon, they sometimes need just basic information about themselves, because effectively these virtual machines go up, they come down. It's a very dynamic environment. So a virtual machine might need to know something as simple as its IP address, and what it can do is it can contact a metadata service in the back to ask basic details like what's IP address, what's my IP address. Now the metadata service should only respond to services to virtual machines that are local, and so you see this box here on the right, which the metadata service and virtual machine can communicate to each other. A couple of other things about this virtual machine, because it was made publicly accessible on the internet, because it needed that to do its job. It was running a web application firewall called NotSoSecure. NotSoSecure is a very prevalent, well-known, and heavily used web application firewall that can be used to restrict what traffic is used to communicate with any applications on the virtual machine instances. So you see that on the right. In the middle of the diagram, in the bottom, are the Amazon Simple Storage Service as a bucket, the S3 bucket that Capital One was using, that stored that 100 million credit card applications. And those buckets, were not configured to be accessible to any and everybody. There was an access control list, an ACL, that specified that the only role, the only user that should be able to access those buckets and the data, the 100 million credit card application, is a role associated with the web application firewall, as you can see here, the ACL *** WAF web role. So those were the key components in the anatomy of the application and the storage services that has been used. Now let me talk a little bit about how the attacker conducted the attack. So our attacker, Heretic, she first made a request to the publicly accessible internet virtual machine instance that was running Capital One's applications and made a request. Hey, can you just tell me what security credentials this virtual machine has? And unfortunately, there was a vulnerability inside the application on the virtual machine instance in which it would take requests from users or anybody on the internet and will relay that onto the metadata service. And this particular vulnerability is called, server-side request forgery vulnerability. Effectively, the attacker's machine is posing as another server that is placing a request to the virtual machine, and there is a couple things that is going wrong here. The first thing that is going wrong is the vulnerable virtual machine instance is actually listening to this request for security credentials. Inside of each, there is a reference to an IP address 169.254, 169.254. That's the IP address of the metadata service. And there are some parameters that comes over an URL on an HTTP request that this virtual machine receives. And the first thing it doesn't validate its data. As you should know, validating the data is an important step that should always be done. And if you don't validate your input, it's kind of like a serious risk. So the first thing is that application running on this virtual machine instance do not validate the input, because this input is definitely not normal. The second thing that is running wrong here is that the virtual machine instance takes this unvalidated input that came in form that came in from the internet, and it passes it on to the metadata services and says, here, metadata services, please evaluate this request. Somebody has asked what security credentials this virtual machine instance has, and it sends it on to the metadata services. Now, the poor metadata service ends up being what's called the confused deputy here, because the metadata service doesn't know if this request is really coming from the legitimate virtual machine instance that should be able to access this information, or it doesn't know it's coming from some attacker's machine. And so the metadata services, when it gets this request, it just happily does its job and says, oh yeah, you have this web application firewall, you have security credentials, access to the security credentials for the web application firewall. So the vulnerable application on this EC2 instance then takes the response from the metadata service and send it back to the attacker machine. So kind of the step one of the attack here, the attacker was able to ask this vulnerable machine, this vulnerable virtual machine instance, what security credentials you have, and get a response. And find out it has a web application firewall credentials. In the next step of the attack, the attacker says, oh, you have this, these WAF security credentials. Can you please send the credentials to me? And when the vulnerable virtual machine instance gets the request, because it has this server-side request for the vulnerability, the exact same thing happens. It doesn't validate the input, and it passes the request on to the metadata service. The metadata service, as I mentioned, ends up being a confused deputy here, because it doesn't know who the request is coming from. To the metadata service, it looks like it's coming from a legitimate virtual machine instance that's running on one of Capital One's application, and he goes ahead and answers. Oh, you would like security credentials? Here you go. Here is the access ID. Here is the secret key. Here is a token. You can use it. Should you want to use those security credentials? So the information, because of the SSRF vulnerability, it gets to the hacker's machine, and the attacker is really now in business now. What the attacker does is take those credentials and caches them in her AWS command line interface, a shell. Hopefully you're familiar with this. It's your command prompt, it's your bash or whatever shell you're using. So pretty much the attacker takes those credentials from the WAF. It should not be accessible to anybody outside Capital One, but she caches it inside her command line interface so that she can use those credentials to do other things. So that was the third step of the attack. The fourth step of the attack, she asked the S3 buckets that Capital One has. Hey, can you please give me a list of all the buckets, all the storage containers that you have? Why should the S3 buckets, why should the storage service listen to the request? Why should it honor it? Well, because the attacker has all the credentials that makes it look that the attacker, kind of is the application firewall in this case, and so the S3 service happily responds with 700 names of buckets that contains the 100 million credit card applications. After that, pretty much the next step is the game over step. The attacker says, oh, okay, so please send me all the data in the AWS S3, and that's what happened. So pretty much all the data was sent out to the attacker home machine running the command line interface as all the WAF credentials. Now, there is a bunch of things that we may talk about. First of all, one may ask, well, why? First of all, one may ask, why should the S3 bucket service, why should Capital One S3 bucket make the 100 million credit card application available to even a WAF role? The WAF is an application firewall. It's a piece of security infrastructure that's used to mediate access. But ideally, if you are following the principle of least privilege, then what you should do is to configure a role only for applications that actually need to use the data. It is unclear to me as to why the web application firewall, while it is a piece of security infrastructure that does need to mediate access, there is no reason why the web application firewall itself needs actual access to the data. So this breach could have been avoided if the role could have been more restrained. And then secondly, there was this server-side request forgery vulnerability in this application running in the EC2 instance, which allowed the attacker to get credentials that only the applications that should be able to access it. So those are pretty much the two good reasons. This is how about Capital One breach occurred. So I went through that in a bit more technical detail than the ransomware breach and the publicly bucket exposure breaches in 2017, but hopefully this gives you a feeling for a little bit more of technical view on how this breach occurred. So given that S3 storage bucket and how bucket exposures had been behind so many data exposures and breaches, I found it might be fun to do an actual example using Amazon services here. So